Today's topic is solving quadratic equations by completing the square. You already know a couple ways to solve quadratic equations. One way is to graph and look for the x-intercepts. Those are solutions. The second way is to factor. Graphing is easy, but it only finds it really when you have whole numbers, and you need to be able to do these kind of things without basically letting the calculator do all the work. So factoring is one way, but not everything can be factored very easily. So this is our second technique, a real technique, and then we have a third one we'll do next class. We'll start with this first example, x squared minus 2x minus 8 equals 0. If you were to graph it, you'd find the answer easy. If you were to factor it, you'd probably find the answer easily. So that's why I start with that. When we already know the answer, we can already find the answer easily, but it also means it's going to work out easily. The good thing about completing the square is it helps you solve equations that aren't easily factored or graphed. But we'll start with one that's really easy, and you have your steps to the right. So we're just going to go through the steps real fast. The first thing we're going to do is we're going to rewrite the equation so it's not equal 0, but we're going to take this number and we're going to move it over to that side. So it's x squared minus 2x, and I'm going to leave a little space here, equals 8. Now we do that because we're going to complete the square. We're going to make everything a perfect square. That's why we spent the time learning how to factor perfect squares by visualizing and seeing it and not having to go through all the work. We want perfect squares. They are simple to graph and simple to factor. So the next step is to divide by a. Well, there's a. It's 1. It's already down to 1, so we're good there. Only time we would do anything is if we had something in front of the x squared. The next thing we're going to do is we're going to take the middle term, negative 2, and we're going to take half of it. We're going to divide it by 2, which is negative 1, and we're going to square that. Negative 1 squared is 1. And we're going to put that in this space, plus 1. But remember, whatever we do to one side, we also do to the other. So we have now a new equation, x squared minus 2x plus 1 equals 9. Okay, so we've replaced the c value. Originally it was negative 8, we moved it over, and now we replaced it with something that makes this a perfect square. You should recognize this as a perfect square of x minus 1. And if you don't recognize it, you've got to go off to the side and factor, which makes this a lot harder to do. Okay, so the next step is we're going to, this step 5, since we already factored it, we're going to take the square root of both sides. Okay, the square root of x minus 1 squared is simply x minus 1. The square root of 9, though, everybody thinks it's 3, and that is true. But remember, we can also multiply negative 3 squared, or negative 3 times negative 3 and get 9. So there's two solutions, two answers. X minus 1 equals 3, and x minus 1 equals negative 3. Now it looks like a zero product property. We solve it twice. We get x equals 4, and x equals negative 2. And our two solutions are x equals 4 and x equals negative 2. If you graph that, you can check it. You can plug those numbers in any variety of ways to check your answers. For our next example, we have one that if we were to try to factor it, we can't factor. There are no factors for 33 that add up to 2. If we were going to try to graph it, we would find solutions, but they would be decimals in there that we couldn't see. So we'd have to do some calculator tricks. So we're going to solve it, again, this new way by completing the square. And the first thing we're going to do is we're going to rewrite it and move the 33 to the other side. The next step, it's already divided by 1 because there's only lead coefficients 1, so we don't have to do it in step 2. The next step is to take this number, take half of it. 2 divided by 2 is 1. If we square that, we're just going to add 1 to both sides. So we get x squared plus 2x plus 1 equals 34. The next step is to factor it. So this is a perfect square. So it's going to be x plus 1 squared equals 34. The next step, step 5, we take the square root of both sides. And the square root of x plus 1 squared is x plus 1. And the square root of 34, we'll leave it like that. But if the square root of 34, it can either be positive or it can be negative. So we have to think of it in both ways. So now we solve both of them. And on this left side, we have the x equals the square root of 34 minus 1. And on the right side, we have x equals negative the square root of 34 minus 1. So that is one of our solutions. or one of our sets of solutions. One way to write it using a radical. But unfortunately for us, most of us don't see the square root of 34 minus 1 and recognize that as what is the solution. So we can, at this point, let's go ahead and pull out the calculators. Let's go ahead and check that. Plug it in, calculate it. And you're going to get x equals 4.83. You actually get on the calculator 4.830955, something like that. We're going to round everything to the thousandths place. It's just much easier that way. So for the second one, we get x equals negative 6.831. Go ahead and check that with your calculator so you see how I got it. But we have two different sets of solutions. For right now, you're going to find them both for me. I want you to find the radical version of it, this one, and then I want you to find the decimal version of it. This next example tried to switch things up on you a little bit. First thing you notice is that there is a number already on the right side, not 0. Doesn't really matter. You're still going to follow the same steps. You're going to take this, move it over to that side. You're going to have x squared plus x equals 42. Okay, there's still no lead coefficient of 1, so we'll leave that alone for now. The next step is we look at this coefficient, and it's 1. We're going to divide that by 2. So we have 1 divided by 2. If we square that, that's 1/4, or 0.25. And you can do it either way you want to. You can go ahead and change to a decimal. So it's going to be plus 0.25 plus 0.25. So you get x squared plus x plus 0.25 equals 42.25. Now, remember, this is called completing the square. You're going to make a perfect square. So if you do this right, you have a perfect square. This would be a square of x plus 1/2, or x plus 0.5. And believe it or not, 42.25 is a perfect square. If we continued our list from before, we'd eventually gotten to 4,225 as 65 squared. Anyway, we still have it in the form x plus 0.5 squared. We take square root of each one, and we get x plus 0.5 equals 6.5, and x plus 0.5 equals negative 6.5, because as I said earlier, the square root of 42.25 is 6.5, so it could be a positive or negative version of it. Now we solve it. In this case, x equals, I'm sorry, not 7. X equals 6. Got to subtract it. On this one, x equals negative 7. So we have two solutions. We have x equals 6 and x equals negative 7. Our last example will have a little bit of everything in it. We have 4x squared plus 16x equals 65. Now it's already set up in the form we want it in, but our second step, this will be the first time we've done that, we have a lead coefficient of 4, so we've got to divide 4 out of everything. And yes, that sometimes will cause some issues, but you just take your time and follow the steps and do the math, and it's okay. So we get x squared plus 4x, I'm going to go ahead and put the space in here, and then it's 65 over 4. 65 over 4 is 16 1/4, so if you want to just write 16.25, go ahead. Now, we'll continue on with the steps, so we're going to take the middle term 4 and divide it by 2 and get 2. So 2 squared is 4, which is what we'll add to both sides. So now we have x squared plus 4x plus 4, which is our perfect square, equals 20.25. And like I said on the last one, if we were to continue going on with our list of perfect squares, we'd eventually gotten to 2025, because that's 45 squared, but we'll get to that in a minute. So this is a perfect square of x plus 2 and 20.25. We'll keep there. Now we're going to take the square root of both sides, giving us x plus 2. And 20.25, as I said earlier, is 45, or 2025. So 20.25 is 4.5, both positive and the negative version of it. So solving, x equals 2.5 and x equals negative 6.5. And we have our two solutions. Okay. Hopefully this helps. I cannot stress enough, follow these steps all the way through. Okay.